So I'm sure you've heard of simulation theory and are we living in the matrix? And we'll kind of get into that a little later, but they have put a real fruit fly's brain inside of an artificial simulation and created a matrix for it. And we'll look at this video.
Scientists just achieved what no one thought possible. They took the entire brain of a living fruit fly, every single neuron, every connection, every microscopic pathway, and uploaded it into a computer. Now imagine this digital brain not as a static diagram sitting idly on a hard drive, but as a living, active system. The moment it woke up inside the simulation, something astonishing occurred. The virtual fly began to sense, react, and even move its tiny body in ways that mirrored a real fly's behavior. It was tasting, feeling, and responding almost as if the brain had truly come alive.
So this digital representation of an actual fruit fly's brain, mapping neuron for neuron, synapse for synapse, actually behave like a fruit fly inside of this matrix, this digital world that it created. It's running on a laptop now. And that asks the question, has this already happened? Are we like the fruit flies in this matrix that's existing now in this reality? And I don't think so, but I think there is a possibility that we'll get into a little later. So we're just kind of going to compare what it takes to do a fruit fly to a human brain. And there's a whole lot of different complexity involved in simulating a human brain. The idea is to go from a fruit fly to a mouse brain and eventually human brain, but it's going to take a while because we'll see the computing power needed to simulate what you got in your head right now. So compare 86 billion neurons to 139,000 neurons, right? And compare what it takes to run a fruit fly simulation, which is pretty much on a laptop, to some of the largest supercomputers on the planet, the Frontier and the Aurora, which are able to handle the amount of computational power it takes to simulate your brain. And that's just one person. So imagine doing this times 8 billion. So the odds of computing power needed to run a simulation for us, pretty staggering. So not only computing power, let's just talk about power as well. So your brain is very efficient, right? It runs on about 20 watts, similar to a small LED light bulb. And if you had to power yourself on AA batteries each day, it would take about 200 batteries to do that. But we know supercomputers aren't powered with batteries, they're plugged into the grid. So let's say you plugged your brain into the grid, you run at about 5 cents per day to cost to run you. And if you did that with a supercomputer, you're looking at about $59,000 a day or $92,000 a day just to simulate one brain, right? So it's very expensive. So imagine doing that on a large scale. So your brain, your biological brain, can do what a supercomputer pretty much it's trained to do now, and at infinitely less cost, right? Just because of your efficiency. So if you were to simulate a reality, and you can argue, oh well, alien technology would be able to do this as efficient, and so on and so forth. And there are some theories with that, but you can just see with our current technology, it would be a huge undertaking to try to simulate each individual on a scale that it would take for to create an actual matrix. So in summary, your brain very efficient, 5 cents a day to run compared to supercomputers, $59,000 a day, $92,000 a day. That's just for one brain. Right now, they simulated a fruit fly's brain, which is 139,000 neurons compared to billions of neurons for a human brain. So night and day. But if you wanted to look at the computational power to run a simulation like this, not looking at classic computers, you can look at the universe as a large supercomputer being able to simulate this reality. So if that's the case and you say reality is a simulation that's simulated by the universe, that's different than saying it's simulated on somebody's computer.